Hi class, this is Miss Cook. Since no one showed up to the review this morning, but I did have a student want me to go over some problems should the review take place, I'm just going to go over those few problems that they asked about and share that with everybody. So I'm going to go over 4 problems from the Chapter 3 review. The first one is number 7, and it says the expression 1 over the quantity 1 minus cosine theta plus 1 over the quantity 1 plus cosine theta simplifies to which of the following? Now this is my problem. Yours might have a slightly different expression. Okay, so this is just to help you practice those trig identities. And one of the first things I like to do is can I switch this and rewrite this in terms of sines and cosines? Well, in this case, it's already in terms of cosine, so that's not going to help me very much. Well, then the second thing I want to do, since I see the word simplifies here, is I want to say, can I get this as a single expression instead of 2 terms? And to do that, I am going to need a common denominator. Well, since 1 minus cosine theta and 1 plus cosine theta share no factors in common, well, I'm just going to say my common denominator. So we are going to first find a common denominator. All right. And that is going to be, I'm just going to multiply the 2 denominators together. Okay. And I know they look similar because they both have a cosine theta, but since I'm adding, those are not factors. Factors have to be multiplied. So 1 minus cosine theta and 1 plus cosine theta, again, they have no factors in common. I can't write them as a product of 2 things that are the same. Okay, so I just multiply them together. All right, so the first term in my sum here, in my original expression, the denominator is missing the 1 plus cosine theta from my least common denominator. So I'm going to multiply the numerator and denominator by that missing factor, which is 1 plus cosine theta. So I get 1 plus cosine theta over 1 minus cosine theta, 1 plus cosine theta. And then the second factor, or the second term in my expression, is missing the other factor of my least common denominator, and that's 1 minus cosine theta. So I'm going to multiply the numerator and denominator by 1 minus cosine theta. Okay. All right, so now we're going to see that when I combine these 2 terms, I'm going to simply now add the 2 numerators together. Well, notice that the cosine and the minus cosine, they're going to cancel each other out, and then I'm going to add 1 plus 1. So now this simplifies to 2 over 1 minus cosine theta, 1 plus cosine theta. Okay? All right, y'all see that? I'm simply adding 1 plus cosine theta plus 1 minus cosine theta together. And so the cosines will cancel out, and then 1 plus 1 is 2. So now this still does not look like anything I have over here in my multiple choice. So I want to then go ahead and simplify that denominator by distributing with FOIL, F-O-I-L. Or in this case, maybe you're comfortable enough with factoring that you can see that this is what's called a difference of squares. And you can use a shortcut there. If you use FOIL, you'll get the same answer. And FOIL is how you get a difference of squares. It's just sort of, you can skip all those middle steps. All right, so essentially what the difference of squares means is when I have a minus b, in this case my a and b are 1 and cosine theta. So when I have a minus b times a plus b, what I get is a squared. In this case, my a is 1, so that's going to be 1 minus b squared when I multiply them together. And my b in this case is cosine theta, so I get 1 minus cosine squared theta. All right, well, what's 1 minus cosine squared theta? Well, this looks like a Pythagorean identity. Anytime you see cosine squared or sine squared, I want you to think of Pythagorean identity. All right, and 1 minus cosine squared theta is sine squared theta. So that denominator simplifies to 2 over sine squared theta. That still does not look like one of my multiple choices. So let's write this expression without a fraction, as not a fraction. So to do that, I'm going to use a reciprocal identity. And the reciprocal identity to sine squared is going to be cosecant squared. All right, so this is really 2 cosecant, 2 cosecant squared theta. And that is my answer. All right, and that's it for number 7. This might be a longer video. Just know that there's 4 problems too. All right, here we are again with the next problem, number 26. I want to solve the equation sine of 3 theta equals -1 on the interval theta is between 0 and 2 pi. All right, so here we have an equation, sine of 3 theta equals -1, and we have an equation where our argument is not just theta. So argument is a little more complicated. So let's go over it. So the first thing I want to do is kind of ignore the argument and think just about sine of theta. So where does sine of theta equal -1? Well, we can look, in our case, just at a unit circle. So I have a unit circle over here. All right. So to find exact values for sine, I always look at the y values, right? And so notice that sine of theta equals -1 at 3 pi over 2 radians. Okay. All right, and I used radians because I have 0 to 2 pi here. Okay, so I'm going to take my clue from that. Well, so sine of theta equals -1 at 3 pi over 2. All right, so now we can bring our argument back into it, because that means that 3 theta, my argument, must equal 3 pi over 2, and then I need to have first the general solution to my problem, to my equation here, because my argument is going to affect how many solutions I have in my interval from 0 to 2 pi. Initially, if I just look at sine of theta, I only have one solution in that interval. But my argument is going to maybe give me some more solutions or maybe fewer solutions. So I do still have to add that general solution. And to do that, you're going to add the period of sine, which is 2 pi, and then the integer k. Okay? So sine of 3 pi over 2 plus 2 pi k. So now what we do is we are going to solve our equation here, and we have another equation in theta, and we're going to solve this guy here essentially for theta. So I'm going to get theta by itself. To do that, I'm going to divide all my terms by 3. Okay, so I get theta is going to be really 3 pi over 6 plus 2 pi over 3 times some integer k. All right, so to simplify that first term there, 3 pi over 6 is going to be 1/2 pi plus 2 pi over 3. Whoop. Times k. All right, so now we need to find the solutions that lie within our interval here from 0 to 2 pi. So to do that, I'm going to plug in some random values for pi, or for k rather. I'm going to plug in some random values for k. I like to start at 0. There may be times where if you have maybe say an interval that's like negative pi to pi or negative pi halves to positive pi halves, that you might start at -1 or something like that. I usually start at 0. Okay? So for k equals 0, I get just 1/2 of pi, or pi halves. Okay? So for k equals 0, I get pi halves. Alright, for k equals 1, I'm going to get pi halves plus plus 3 pi, or 2 pi over 3. Oh, 2 pi over 3. Alright, but then that gives me, I believe, 7 pi over 6. Yeah. Alright, so now we're getting kind of close there. So let's make sure that 7 divided by 6, it's not quite 2, but you can always check it if you're concerned by just going to your calculator here. 7 divided by 6. Alright, we're still, that fraction or that ratio, you want it to be less than 2 because then you're still within that 0 to 2 pi. So we're safe. We get 1.1. So this is still an okay solution. And we've got 2, so let's see if we can find a third solution. So when k equals 2, I get pi halves plus pi halves over pi, 2 pi over 3 times 2, which is 4 pi over 3. So I get pi halves plus 4 pi over 3. Okay, and then from there I get 3 pi over, this is going to be, 3 pi over 6. I'll work this out a little bit more in detail. Plus 8 pi over 6, which is 11 pi over 6, which is still not quite 2 pi. Okay? But I guarantee you if we go up to k equals 3, then that will be over 2 pi. So those are my 3 solutions. Notice how, and this may not happen every single time, but it sometimes does show up as a pattern. Notice how when my argument was just theta, I had one solution, but when I added 3 times theta as my argument, that 3 there changed my period, and now I'm going 3 times as fast around the unit circle. So now I have 3 solutions. Okay? So that's number 26. Alright, so we are now going to do 42 and 43. So 42 says if sine of theta is 2 over 3 and theta is between 0 and pi halves, we want to find the exact value of each of the following. So A is sine of 2 theta. So here we're going to use our double angle identities, and some half angle identities for C and D. The first thing I need to do is pull out my formula cheat sheet to see what I need. So for the double angle, it looks like the first one for sine of 2 theta, I am going to need the value for sine theta, but I also need the value for cosine theta. Okay, so it looks like that's the first thing I'm going to have to do is find cosine theta. And I'm going to eventually need that for the half angle formulas as well anyway. Okay, for C and D. So in order to find sine of theta, I'm going to use, or cosine theta, I need to use the information they already give me for sine of theta. Okay, so sine of theta equals 2 over 3. Well, we know that sine theta equals y over r. Okay, and we know that cosine theta equals x over r, which is 3. So we need to find x. Okay, so that's where our quadrant here comes in. If theta is between 0 and pi halves, that means that we are in between 0 and pi halves. That means we're in quadrant 1, which means that both x and y are going to be positive. If we were told, say, that we were in the interval between pi halves and pi, then that means we're in quadrant 2, and we would have to make our x value negative, right? But we are in quadrant 1, so we're going to pick the positive value for x. Okay, whoops. All right, so to solve for x, we have the equation r squared equals x squared plus y squared. So then that gives us the equation x equals the square root of r squared minus y squared. Okay, if we were to solve that first equation I wrote. All right, so now we just plug in r and y. And we said that r is 3, so 3 squared is 9. And y is 4, or y is 2, so y squared is 4. I jumped ahead of myself again. So we get the square root of 5. So x is the square root of 5. Again, we're going to pick the positive solution because of our interval here. All right? There still are 2 solutions technically to a quadratic equation, which this is, but since we are only looking at one of them, we will only take that one because the other one lies outside of our interval. Okay, so now we know that cosine theta is root 5 over 3. So that's the hard part. Now we just have to come and use our formulas here in order to put things together to solve for A, B, C, and D. All right, so for part A, I need sine of 2 theta, so I'm going to use this double angle formula. So the sine of 2 theta equals 2 sine theta times cosine theta. I'll write the formula first, and then we will plug things in. Well, we know what sine theta is, and we know what cosine theta is now. So I just plug in 2 times 2 over 3 times root 5 over 3. Now at this point I look at my blue text and it says type an exact answer. So unfortunately this means I cannot necessarily use my calculator. I'm just going to have to multiply this out by hand. Because of this square root of 5, my calculator is not going to give me a nice answer. It's going to try and give me a decimal. Alright, but I just multiply. 2 times 2 is 4, and then I'm going to leave the factor of root 5 there, so 4 square root of 5. So 2 times 2 times the square root of 5, and then 3 times 3 in the denominator gives me 9. Okay, so that's the first answer. So that was A. For B, I need cosine of 2 theta. So again, I'm going to come back to my cheat sheet here. So cosine of 2 theta equals cosine squared theta minus sine squared theta. Okay, very similar, kind of similar-ish to the Pythagorean identity. So cosine of 2 theta. All right, make sure I get them in the right order here. Leave cosine comes first. Yeah, cosine squared. Y'all, even I don't always have these fully memorized every time I teach this class. So, it is okay. All right, so cosine squared theta minus sine squared theta. I'll make that look like a minus sign there. So then once again, I just plug in now cosine and sine, the values there. So cosine of theta was root 5 over 3. And I'm going to square that, and then I subtract 2 over 3, and I'm going to square that. All right. So root 5 over 3 squared is going to be 5 over 9. And then 2 over 3 squared is going to be 4 over 9. I subtract and I get 1/9. So that maybe we could have put in our calculator. The first one we couldn't. That was going to give us too complicated of an expression as a decimal in our calculator. All right, so part C is now moving into the half angle identities. All right, so I believe sine was first, so sine of theta over 2. I have this formula here. So sine of alpha over 2, or theta over 2, equals plus and minus the square root of 1 minus cosine of alpha divided by 2. Okay? So I need to know which one to pick. Yeah, we said that our theta lies in quadrant 1, so theta over 2 is going to be in quadrant 1. So that means we're going to pick the positive value. Okay? So remember, when you're looking at the half angle formulas, you want to look at the quadrant of theta over 2 or alpha over 2. You're going to pick whatever quadrant that lies in to determine where, or your theta over 2 lies in. You're going to use that to determine if you're using the positive or negative part of that solution. Because sometimes it will change, okay? Your theta may be in one quadrant, but then your theta over 2 is going to move over a quadrant. Well, in this case, we're all in quadrant 1, so we don't have to worry about it. Our original theta is in quadrant 1, so theta over 2 is going to also be in quadrant 1. If theta was in quadrant 2, maybe dividing that angle in half is going to move it over, say, to quadrant 1. All right, so now let's use that information and my formula from down here to go ahead and answer the problem. Okay, so I'm again going to use the positive solution. Okay, and that's 1 minus cosine square root of 1 minus cosine over 2. Perfect. All right, so now we just plug in cosine theta, which was the square root of 5 over 3, and divide by 2. All right, so in the numerator there, I have a fraction on top of a fraction, and so that is going to simplify to 3 minus root 5 over 3, and then divided by 2. So that gives me a solution then of, when I simplify those two fractions together, or divide those fractions, I get 3 minus root 5 over 6. All right, and I don't think I can really simplify that much more than that, so that's going to stay the way it is. Sometimes you'll get one where you can simplify the denominator a little bit, but in this case, we couldn't. All right, then part D is going to go similarly for cosine of theta over 2, except I have 1 plus cosine of alpha over 2 in my as my identity here instead of minus. So that gives me cosine theta over 2 and I believe all that's going to change here is I'm going to change all my minuses to pluses. Yeah. 1 plus root 5 over 3 divided by 2. All right, sorry about that. I had to quickly rewrite a few things here. So I get 3 minus root 5 over 3 divided by 2, or plus, which gives me the final answer of 3 plus root 5 over 6. Okay. And that is our final answer for number 42. Okay, let's go ahead and work 43. It's going to be somewhat similar to the previous example, but we are now given cosine of theta instead of sine theta, which is negative square root of 6 over 3, and we are also given that our theta lies between pi halves and pi, which, if you remember from before, between pi halves and pi, this is going to put us in quadrant 2. All right, and in quadrant 2, our x value is negative and our y value is positive. All right, so that means that this negative hanging out here with our cosine of theta value, that's going to go with the x, okay? So whatever y we find for cosine is going to be positive, so cosine of theta will be, or sine of theta rather, will be positive, okay? So our sine of theta will be positive. Our cosine is going to be negative because we're in quadrant 2. Okay, so we get to find sine of theta first. All right, so kind of using a very similar method as before, we know that cosine of theta is x over r, and in this case my x is negative root 6 and my r is 3. R is always going to be positive, so that negative sign, if you outside of your trigonometric value, is always going to go with the x or the y. All right, and then sine of theta is y over r, and in this case r is 3. So using a similar method to what I did previously, y is going to be the square root of r squared minus x squared. Same thing except x instead of y, okay, underneath my square root. So now I plug in x and r underneath my square root here. So r is 3, and then x is negative square root of 6, squared. Oh my goodness. So include my negative sign there. So when I simplify that, I get 9 minus 6, because negative square root of 6 is going to square out to positive 6. That square is going to make that value positive, because a negative times a negative is a positive, and it's also going to cancel out that square root. All right, so then that means I get y is equal to the square root of 3. And again, since we are in quadrant 2 and sine and y are both positive in quadrant 2, I'm going to pick the positive value for y, not the negative value. Okay. So that means that sine of theta is root 3 over 3. So now we do the same thing that we did in the previous example. So A, let me move down just a little bit. So for A, I get sine of 2 theta. All right, equals my cheat sheet. So sine of 2 theta is 2 sine theta cosine theta. right? But sine theta we found was root 3 over 3. And then cosine theta was given to us, and that's negative root 6 over 3. All right, so how do we multiply all this together? Because we need an exact value, and we have radicals in here. So we want to make sure that we don't automatically jump to the calculator, because your calculator may not give you an exact value when it involves radicals. All right, so I'm going to still multiply straight across. 2 times the square root of 3 times the square root of 6. But when I multiply two radicals together, I just multiply what's underneath. So 3 times 6 is 18. So I get negative 2 times the square root of 18 over 3 times 3, which is 9. Okay, but now I can maybe simplify the square root of 18. So to do that, I can break 18 down into not 3 times 6 necessarily, but maybe 2 times 9. Okay, because the square root of 9 is 3. So 9 is a perfect square. Alright, so really I get negative 6 when I pull out that 3. That square root of, when I pull out that square root of 9, that becomes 3. I multiply it to the 2, and that gives me negative 6, and then I'm left with root 2 over 9, and then I can simplify that one last time to negative 2 root 2 over 3. Okay? Alright, so that's the first answer for part A. For part B, we have cosine of 2 theta is cosine squared theta minus sine squared theta. Alright, so now we just need to plug in cosine and sine. So that is negative root 6 over 3 squared minus root 3 over 3 squared. It ends up not being too bad, it looks like, because I'm going to get, so now remember that when I square that negative, it's going to become positive, and then when I square that radical in both terms, then the radicals goes away. So I get 6 over 9 minus 3 over 9. Now I'm just going to leave it there for now because it's going to be easier for me to subtract the fractions if I do, because that gives me 3/9, and then now I'm going to simplify to 1/3. Okay. Alright, and then C, now we have our half angle identities. So am I going to use the positive or negative versions for my two values here? So we have to think about this for a minute. So sine of theta equals negative root 6 over 3. So let's go ahead and use an inverse sine function to determine what that value will be. Okay, let's find out what theta is, because we want to make sure that we stay in the same quadrants. Alright, so second cosine, and I don't care if this is in degrees or radians, I am just using this to determine where I'm at. Okay, so cosine inverse of negative second x squared 6 over 3. Okay, and I get 144. Now let's divide that by 2. And I get 72. So notice now that we have moved into quadrant 1, which means I'm going to use both the positive, I'm going to use the positive options for both our half angle identities. So even though theta was in quadrant 2, theta over 2 is in quadrant 1. Okay? All right, so we are going to use the positive solutions to both of these. So sine, because sometimes it'll move a quadrant, sometimes it won't. Most of the time you'll find it will, though. Okay, so I believe that this was the square root of 1 minus cosine theta over 2. All right, and then cosine theta was minus root 6 over 3. Okay, simplify this a little more. The two negatives here make a positive. All right, which is 3 plus root 3 divided by 3 over 2. All right, which is the square root of 3 plus root 3 over 6. And I can't really simplify that. I know it's tempting, but I need to have a common factor in both, with the denominator in both terms of my numerator, so I can't really change that. All right. So then with cosine theta, we're going to have a very similar thing, except when I work it out, that negative and a positive is now going to be a negative minus root 6 over 3 over 2, and so using very same methods I get 3 minus root 3 over 6. All right, and that's pretty much it for those. All right, let me know if y'all guys have any questions. I am going to include timestamps because this is a longer video. All right, y'all have a wonderful day.